This next section, 29.3c, is of the third of the four gas giants, the Jovian planet known as Uranus. It's the seventh planet from the Sun, and it's the next Jovian gas giant. It's the third largest in the solar system behind Jupiter and Saturn, respectively. It's the only planet named after a Greek god, Uranus, almost like Thanos in the old movie series of not too long ago. All the rest of them are named after Roman gods. It's the coldest planet that we know of from our observational data, with an average temperature of minus 220 degrees Celsius. Remember, minus 273.15 is absolute zero. It's been only observed by spacecraft once, and that was a Voyager 2 back in 1987. But it was the first planet we also discovered by the use of a telescope, and this was done by Sir William Herschel in 1781. So the telescope that had been invented in the 1690s, almost 100 years later, a little better than 100 years later, somebody actually found a planet using the telescope. It was the first. Here's an artist's depiction of the Voyager spacecraft going by the planet back in 1987. Give you an idea where it's at. There's Jupiter, there's Saturn, and the green ring here is the planet Uranus. So you can see as the rings expand, the distances grow greatly. Its atmospheric gases, about 82.5% of it is hydrogen, so it's another one with a lot of hydrogen. But in this case, it has about 15.2% helium, so it's higher than Saturn. And 2.3% of it is methane. Same material that comes out of the gas jets in the lab. It's this latter gas, being at that level, that gives it kind of a green-blue color. It's also comprised of hydrogen sulfide gases, so if you could smell it, it smells like rotten eggs. And the interior has liquid metallic hydrogen, something that we thought, or we think we've made in the lab just recently. And it's not after lack of trying. And it's surrounded by a liquid mixture of methane and then water, which interfaces with a solid metallic hydrogen core. It's at this liquid hydrogen methane boundary that the condition is such that it could possibly rain the carbon allotrope diamond. Allotrope is just a form of carbon. If you go to the gardens in St. Louis, you have the buckyball domes over the rainforest and the desert and the show domes in the gardens. That's another allotropic form. When you get to that level here, there's enough pressure and with the carbon compounds to form diamonds. The axial rotation is 17 hours and 14 minutes, and it has a tilt of 97 degrees. So basically it rolls on its side. And so each hemisphere of the planet has a 42-year-long day, followed by a 42-year-long night. There's also a modest magnetic field that generates as much heat as it gets from the sun. So where Jupiter and Saturn are double, generating twice as much heat as they receive, this is almost a one-for-one exchange. The heat it gets from the sun is about what it generates internally as well. So roughly it's 4 times wider than Earth, with a diameter of about 50,700 kilometers. And its average wind speeds are about 570 miles an hour, so about half as much as we saw on Saturn's surface. But it's it's known for being very cold and its color. And these are the actual images of the Voyager when it was coming closer. As you can see, its Kepler values, its P, or basically its rotation about the sun, one orbit takes about 84.12 Earth years. and it's sitting out there at 19.2 astronomical units, with a perihelion of 18.3 and an aphelion of 20.1. So a little more elliptical than Saturn's. But for all the planets, it's the greatest range of values. And again, we're talking about the 8 planets. To date, it has 27 known moons, and they've named them after English literature characters, and they basically fall into 3 categories. There's 13 inner moons as being one of them, and they're connected with the rings of Uranus themselves, so they're part of the ring system. There's 5 major moons, which oddly have the same axial tilt as Uranus. So when Uranus is rolling on its side, so are these guys. They're rolling on their sides. And there's 9 irregular moons that are the furthest orbits from the planet, and these paths run in all directions. So the 13 inner with the rings, 5 that roll on their side like the planet itself, and then the other 9 that are farthest out, and they go all over the place. And there's just basically a listing of the moons in the graphic next to us. And this is the orbital paths. So you can see you've got these outer ones that are just all over the place. The planet has 13 known rings, hence the 13 inner moons, but they're very narrow, and these are very dark. They're very difficult to see. They have low albedo, so low reflectance. The reflectance rate is about 2, or similar to wet mud, just about as much as wet mud reflects light. Only one of these rings has a shepherd moon, one that's actually in the ring clearing out the debris. This is the actual of the flyby, so you can see the ring system as you're going by. One of the moons, Cerberus, is not only very tiny, about 48 kilometers across, about the size of Alton, it's also very dark. Its albedo is 0.04, or total black is 0. So for your artists, this thing's just slightly, almost perfect black. It also goes the wrong way. It travels in the opposite direction of all the other moons. So this little guy is going on its own path. And there is a snapshot at when this Voyager went by. Its moon, Marguerite, is the only moon in the solar system that orbits in a prograde orbit that is perpendicular to the normal orbital plane, parallel to the equator of the planets. So here's, in fact, this is one of the trackers you'll see that you'll be able to view that we do it in real time. This guy, where everybody else is going this direction, this one's going at a 90 degree. And that's the end of this section for this planet. That's about all we know.